Hello, and welcome to Code Next Door. My name is Andre.
And my name is Chris. And today we're going to be talking about Lisp. So, in order to get started with Lisp, which stands for list processing, we need to install a Lisp. There are many Lisp. The ones that we will be working with today, it falls under Common Lisp, and we will be installing SBCL. If you're running on a Mac machine, I'd say the easiest way to get this is by doing brew install SBCL. If you don't have brew, you can install from source by going to the website for SBCL. It looks like this, sbcl.org, and they have um, a live binary for you to install here, or you can build it from source, whatever you like. Once you have a Lisp installed, we will want to have some way of editing that Lisp code. I highly recommend using Emacs. It has a bunch of cool features built in to work with Lisp-like languages, and it's really awesome. So in order to do that, like you can use Brew as well. Brew install Emacs, or you can build from source or download executables from GNU. And the links will be in the description. So assuming you've gone through the steps and have installed SBCL and Emacs, start a terminal and let's just look at what SBCL has to offer. So if we type in SBCL, this starts a REPL, read, evaluate, print, loop type of program. And I will start to go over the basics of what Lisp has to offer in this REPL. So in Lisp, you essentially have two types of data. You have list, and then you have atoms. Atom, it can be a number, it can be a string, and a string in Lisp is just anything inside quotation marks. So, hello world. You can have binary, and you can have hexadecimal. Yeah, I don't know hex off the top of my head, but these are all atoms. And then the other thing you can have in Lisp are list. And in order to make a list in Lisp, you start with the open parentheses and a closing parentheses. And because I'm using Emacs, I have pair edit, which helps me like write parentheses faster. So you can put your atoms inside of your list, and you can have lists inside of your list. So you're probably wondering now, well, how do we code or do anything with these lists? So in order to add things on lists, we'll cover that first. When you want to actually evaluate some expression and not just have it represent the data, you write a list, and this list is going to be special. The first thing in this list is going to be a function, and then every other element in this list is going to be arguments to that function. So here we have the addition function, and we're passing it the arguments 1, 2, and 3. So we should see the result of 6, which we do. So Lisp takes the first element of the list, treats that as a function name, looks up that function, and then evaluates the rest of the elements of the list with that function. So how do we define functions? So you start off with a list, which is just open parentheses, and then we use this word defun, which you can kind of say stands for define function. And then we pass it as the second element in this list, the name of that function. And then as the third element in the list, we pass it a list, and this list will contain all of the possible arguments to the function name. The fourth element in the list is your documentation string, and this is essentially like how you document things. And then finally, the fifth element is the actual body of your function. So if this is valid Lisp code, and because I'm using Emacs, I can press Control C, and this automatically evaluates in my repo on the left. And this is sort of how people go about coding in Lisp: is they write something and then they evaluate it, and they write something else, evaluate it, and back and forth. And we already know how we use functions. We put them in the first position of the list, and then we call them with their arguments. So list functions also accept keyword arguments. So say we had a Caesar cipher function, and we want to essentially pass it some passcode to encrypt. And well, by default, we want the cipher to be 1, but we would like to offer to the user the option to pass in some other key so they can change the cipher to be something else. So Lisp offers the ability to define keyword arguments. So we have our first element, which is the defined special keyword, then the function name, Caesar in this case. Then we have the list of arguments that the function will take. And this is the syntax for defining a keyword argument. So you did ampersand key, and then a list of arguments and the default value for that arg. So if we compile this, Caesar, and I come over here and use it, we get IFMMP. And that's just what happens if you shift each letter by one character in the cipher, but say we want it to define our key to be something else. So our key is called cipher, and we pass it 4. And now it's changing our key by 4. So those are keyword arguments. And similar to keyword arguments, we also have optional arguments. And these are arguments that just don't necessarily have to be there. So if we have the hello world function here, we have our list of args, and then we have the ampersand optional, and then message is an optional argument that we can pass. So if we compile this by pressing Control C, now we have access to that hello world function, and let's run some examples. So if we just run hello world by itself, it prints out hello world. If we run hello world with Chris, it prints out hello Chris. And if we want another example here, hello world Andre, it prints out hello Andre. Okay, so that's how you define functions in Lisp, which I think is the most important part of a programming language. After that, I would say you have the special forms of the language. So you have if statements and conditionals. So Lisp has if statements. So in order to have an if statement, you write if, and then the thing that you actually want to test, your conditional. So let's say if we have an equal function, if 3 is equal to 4, then we want to return nonsense. And if it's not equal to 4, we want to return obvious. So this if statement is going to clearly return obvious, right? Because 3 does not equal 4. But that's how you do a simple if statement. You have if in the first position, then you have your test in the second position, then you have your truth statement, like what happens if the statement is true on the third position, and in the fourth position you have what happens if the statement is false. Now, you might find yourself doing a lot of these types of if statements, where in other languages you would see like a if staircase, where you just have a bunch of branches that keep branching off, and then you want to handle a bunch of different cases. And usually you have like a case statement, but in Lisp we have con. So con just takes a list of statements and results from those statements, and it tries to match. So if the first statement matches, then it's going to return this result. If the second statement matches, it will return that result, and so on and so on. So if I create a variable, which we learned how to do earlier using def var, and I call it x, and I'll just make it 3 for now. And I have a con statement here that says, is x equal to 3, return 4. If x is equal to 4, return 5. And this can go on, so on and so on. Okay. So x is equal to 3, so it returns 4. All right. So we have ways to define functions. We have conditional statements. Now, next we would talk about some form of iteration, but I don't really like iteration, so we're going to talk about recursion.